Hello my precious friends, I really hope that you are doing great. Welcome to today's class. It's our fourth lesson on a given form 3 mathematics topic called formula and variation. So we are looking at our example number 12, which is also a past Kcse question done in 204, paper 2 question number 9. So the question reads that make B the subject of the formula A is equals to BD divided by the root of into bracket B squared minus D. So the first step, I'm going to eliminate the root, so by squaring both sides of this particular equation so that I can do away with the root. So I'm going to square this side, I also square this other side. So I'm going to get on the left hand side, I'll get a squared being equal to, so of course this one means that the square will affect both the numerator and the denominator. So this will be BD, I square the numerator, then divided by, we also square the denominator, which is actually the root of into bracket B squared minus D. I also square this. So of course the square and the square root are going to cancel out, so the square root and the square will cancel out, so that I'm going to remain with S squared being equal to, so this one will give me B squared D squared, then the whole thing divided by B squared, then of course minus D. So this is of course over 1. Then I'm going to cross multiply so that this one will cross multiply with A. So I'm going to have A squared, then into bracket B squared minus D being equal to 1 multiplied by B squared D squared. I'll simply get B squared D squared. If I open the bracket, I'm going to get A squared B squared, then minus A squared D being equal to B squared D squared. Then I can separate my working using a straight line this way. So this means that I'm going to remain with, so we need to make B subject of the formula, so I'm going to combine the terms having B. So that means I'll take this term to this side because it has a B. Then the term missing a B, I'll take it to the other side. So I'm going to have A squared B squared. If this one crosses the equal sign, it will become a negative. So I'm going to have minus B squared D squared being equal to, on the other side, I'm going to have positive A squared D, A squared D. So this is A squared B squared, then minus B squared D squared is equals to positive A squared D. So if I factor out B squared, because it's common, I'll have B squared, then into bracket. So here I'll remain with A squared, then of course minus. Here I'm going to remain with D squared minus D squared, which is equals to A squared D. So I'm going to divide through with the number in the bracket, which is A squared minus D squared. I also divide with A squared minus D squared. So these two will cancel out, so that my B squared will actually be equal to A squared D, then of course divided by A squared minus D squared. Then I'll take square roots on both sides so that I remain with B. I'll take square root on this side and also on this other side, but remember square root is a plus or minus, so that one means that the value of B will actually be equal to that is the root of, so this will be plus or minus the root of the numerator I'm having A squared D, then divided by the denominator I'm having A squared, then minus D squared. Or remember, this is also a difference of two squares, so you can also talk of B being equal to plus or minus the root of, I'm going to have A squared D, then divided by, this is a difference of two squares, so I can write it as A plus D, then into bracket A minus D. It is simply the same thing. So either this solution or this other solution are both acceptable values of B. Then we look at our next example, which is example 13, which is also a past Kcse question done in 205, paper 1, question number 10. We are told to make P subject of the formula given that P squared is equals to P minus Q into bracket P minus R. So the first thing I'm going to do is to expand the right hand side of the equation. So this will be P squared being equal to, If I expand, I'll get P into P minus R, then of course minus Q into P minus R. So this will give me a P squared actually being equal to a P squared. Then P times negative R, I'll get negative PR. Then negative Q times P, I'll get negative QP. Then negative Q times negative R, I'll get a positive QR. Then let me check if we have like terms. Yeah, we have P squared. If this one moves to the other side, it will be a negative. So we'll have P squared minus P squared being equal to, on this side we are still having a negative PR. So we have negative PR, this term here, then minus QP, which is this term here, then plus QR. So of course P squared minus P squared, you are going to get 0. So 0 is equals to negative PR, then of course minus QP, then of course added to QR. So we need to make P a subject of the formula. Therefore I'm going to combine the terms having P on one side such that I'll try to make them positive. So this term has a P, this one also has a P. So for me to make them positive, I'll take them to the other side of the equation. So that I'm going to have positive PR, then of course plus QP being equal to, on this side I'm still remaining with QR. Then I'm going to factor out P because it's common, so this will be P into R, then of course plus Q being equal to QR. So R plus so this will be R plus Q being equal to QR. So if I want to find the value of P alone, I'm simply going to divide through with the number that is in brackets, so that I'm going to get the following. If I divide through by the number in the bracket, which is R plus Q, I also divide by R plus Q. So of course these two will cancel out. So my P will actually be equal to QR, then of course divided by R plus Q, which can also be rewritten as P is equals to QR then divided by Q plus R, or you can also rewrite it as P is actually equal to RQ, then of course divided by R plus Q. So either of the answers are both acceptable. So either this one or this. Then we move to our example number 14, which is also a past Kcse question tested in 206, paper 2 question number 2, which reads that make S the subject of the formula, the root of P is equals to R, the root of 1 minus AS squared. So the first thing I'm going to do is to square both sides so that I can do away with the root. So I'll square this side, I also square this other side. So if I square both sides, of course this one the square root and the square will cancel out. So I'm going to have P being equal to, on this side I'll have R squared, then of course into bracket the root of 1 minus AS squared, then of course it is squared, so that the square root and the square are going to cancel out. So I'm going to remain with P being equal to, so P will be equal to R squared into bracket 1 minus AS squared. So this will be P is equals to, so this will be R squared minus AS squared R squared. So we need to make S subject of the formula, therefore I'll take it to the other side, then I take P to the opposite side, so that I'm going to get, I'm going to have positive AS squared R squared being equal to R squared minus P, R squared minus P. If I want to remain with S alone, I'll divide through by AR squared, so divided by AR squared, also divided by AR squared. So this and this will cancel, this one will also cancel out. So I'm going to remain with S squared being equal to R squared then minus P divided by AR squared, AR squared. So this one simply means that my P will actually be given by, so that is my S. So I'm going to take square roots on both sides. I'll take square root on this side and also square root on this other side. Square root is plus or minus, so it means that S will actually be given by plus or minus the root of, plus or minus the root of r squared minus p, then of course divided by r squared minus p divided by ar squared, so that is our s. Remember that this one you can also decide to rewrite it, which is equal to plus or minus the root of. You can also write it this way. You can take r squared, then divided by ar squared, then you subtract p divided by ar squared. So remember, ar squared and ar squared are going to cancel out, so this one will cancel out with this, so this will be 1. So that means that s can also be given by plus or minus the root of, so this one will remain as 1 over a, so this will be 1 over a, then of course minus p divided by ar squared. So either this or the first equation here, either this one or this, both are acceptable. Then we look at our question number 15, which is also a past Kcse question done in 207 paper 2 number 2, which reads that given that y, we are given that y is equals to 2x then minus z, then divided by x plus 3z. So express x in terms of y and z. So we simply need to make x subject of the formula. So the first thing, I'm going to cross multiply. So I'm going to have y into bracket x plus 3z being equal to 1 multiplied by 2x. So I'll just get 2x minus z. If I open the bracket, I'm going to have yx then plus 3yz being equal to 2x then minus z. Now they want us to make x subject of the formula, therefore I'll group the terms having x. So I'll take this term to this side and this other term to the opposite side. So I'm going to have on the left hand side, I'll have yx then of course minus 2x being equal to yx minus 2x will be equal to, if this one moves to the other side, it will be negative z, then of course minus 3yz. So I'll factor out x because it is common. So I'll have x into bracket y minus 2 being equal to negative z, then minus 3yz, Then if I divide through with the number that I'm having under the bracket, I'm going to get the following. I divide through by y minus 2. I also divide through by y minus 2. So these two will cancel out. It means that x will actually be equal to negative z, then of course minus 3yz, then the whole thing divided by y minus 2. Which can also be expressed as, if I decide to multiply through by negative in both the numerator and the denominator, if I multiply through by negative, this will be positive z, then this will be positive 3yz, then divided by, this one will be negative y, then of course plus 2, which means that you can also express it as x is equals to z plus 3yz, then divided by 2 minus y. So either this answer or this one are both acceptable answers. Then we look at our example number 16, which is also a past Kcse question done in 208 paper 2 question number 2, which reads that make h subject of the formula. So of course the first thing is simply to cross multiply so that we eliminate the fraction. So this will be q into 1 minus ht, which is equal to 1 plus rh. If I open the bracket, I'll have q minus qht, which is equals to 1 plus rh. We need to make h subject of the formula, therefore I'll group the terms having h, and the ones lacking h, I'll also group them to the other side. So I'll get q minus 1 being equal to, on this side I'm having rh, then of course plus qht. So because h is common, I'm going to factor it out. So I'll have h into bracket r plus qt, which should be give me q minus 1. Then I'll divide through with the term in the bracket, which is r plus qt divided by r plus qt. So this one means that I'm going to get the following. So this one is going to give me, I'm going to have, so this will be, of course these two are going to cancel out, so it means that h will be given by q minus 1 then divided by r plus qt. Or the same term can also be written as h is equals to q minus 1 then divided by qt, of course, plus r. Or you can also write it this way: if you multiply through by negative both on the numerator and the denominator, you are going to have this one will be negative q, so I'll get negative q plus 1 then divided by, on the denominator both will be negative, negative qt then plus, no, minus r, negative qt minus r, so it will be a minus. Remember, I'm multiplying through by a negative both on the numerator and the denominator, so this will be negative q plus 1 then divided by negative qt, then of course minus r. So either of the answers are acceptable, either this answer here or this one here or this. So those are possible answers. Then we look at our example number 17, which is also a past case question done in 2010, paper 2, question number 14. It reads: make x the subject of the formula 3y is equals to y plus p over q plus 1 over q. So the first thing is to eliminate the fraction. So I'm going to multiply through the LCM. So the LCM in this case, of course, is the LCM will just be this denominator, which is q. Let me rewrite it here. So I'm having 3y being equal to y, then of course plus p, then the whole thing divided by q plus 1 over x. But remember, these are like terms, these two are like terms, so I'm going to get 3 minus y, so this is the same as saying 3y minus y being equal to p, then of course divided by q plus 1 over x. So this one would remain to be 2y being equal to p, then of course divided by q, then plus 1 over x. So then I'll multiply through the LCM, which is simply q plus 1 over x. I also multiply this side with the LCM, so multiplied by q then plus 1 over x. So these two are going to cancel out, this one and this, so that I'm going to remain with the following. Let me separate the working. So I'm going to remain with 2y, so this will be 2y, then of course into q plus 1 over x, which should be equal to p. Yeah, so this will be 2yq, then plus this one will give me 2y over x, which is equals to p. Still we have a fraction, so to eliminate the fraction I also multiply through by the LCM. LCM is x, so I'll multiply this by x multiplied by x by x, so the x will cancel out here. So it means the answer would remain to be 2yqx, then of course plus 2y is equals to px. So remember, we need to make x subject of the formula, so I'll take this to the other side, then this one to the opposite side. So I'm going to have 2yqx, then of course minus px being equal to the negative of 2y. So this is 2yqx minus px is equals to negative 2 that. So of course x is common, so I'll factor it out. So I'll have x into brackets 2yq then minus p, which is equals to negative 2y. So this is going to give me the following. So I'm going to divide through by the term under the bracket. So I'm going to divide through by let me cross check this. This is 2yq, correct, minus p, which is that. So I'll divide through by 2yq, then of course minus p. So divided by 2yq minus p. So these two are going to cancel out, so that my value of x would remain to be the negative of 2y, then the whole thing divided by the whole thing will be divided by 2yq, then of course minus p, which can also be rewritten as, if I multiply through by negative both on the numerator and the denominator, this will be positive 2y, then divided by, this will be negative 2yq, then this will be a positive p, which can be written as x is equals to 2y, then divided by p, divided by p, then minus 2yq, p minus 2yq. So either this solution or this one, they are both acceptable solutions. So in our next class, we'll be looking at further examples on this particular topic. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you will get notified. Until next time, this is Kind Tuition Academy. Thank you.